Today we will be looking at how to add two fractions with different denominators. Before we get into that, let's do a quick recap of how to add fractions with like denominators. Let's say we had a rectangular box, and this box could be anything. It could represent, let's say, a candy bar. And we were to split this candy bar into 4 equal pieces. Because it's in 4 equal pieces, well, my picture is not drawn to scale, so they do not look equal, but we want them to be equal. Then, of these 4 pieces, each one represents 1/4. And so, the denominator of our fraction tells us how many pieces we broke our whole into. We broke our whole candy bar into 4 pieces, so we have the denominator as 4. Now let's say I wanted to take 1/4, one piece of the 4. Then I would have 1/4. What if I wanted to add that 1/4 to, let's say, 2/4 of the candy bar? Then I would have 2 out of 4 over here. What would my answer be? Well, it would be the 1 of the 4 that I chose, and the additional 2 of the 4, which would make it 3, but of the 4. And so when we add two fractions with a common denominator, we always keep the denominator in the answer and simply add the top or the numerators. And so 1/4 and 2/4 will always give us 3/4. Now, let's try this with adding two fractions with different denominators. Let's say we have the same candy bar. I'm going to keep it. We don't necessarily need the coloring inside of it, so I'll take it out. And let's say we had another candy bar that's of equal size, equal length, equal everything. Doesn't look like it in my picture, but again, forgive me, it's not really drawn to scale. And let's say I want to slice this one into thirds. And now, actually, maybe we will color it. Let's say I wanted to add 1/4 and 1/3 of the candy bar. Right away, we see where we have a problem. It's hard for us to express both these two different candy bars as one number because 1/4 is referring to this piece, while 1/3 is referring to this piece. And as you can see, they're of a different size and shape, which is why the 4 and the 3 are different. So how can we express them into one number? That's the only way we'll be able to add these two fractions. We need to somehow compare both of these on the same level so that they're comparable. So we need to have a common denominator for these two fractions. How can we get a common denominator? Well, we need to change both these numbers into one number that's common to both of them. And the best way to do that is to multiply both numbers. 4 times 3, which gives us 12 as our denominator. That means if we could somehow change this 4 to a 12 and change this 3 to a 12, then we will have a 12 at the bottom, and now we could compare each fraction. First, let's work on our picture. How could we do this? Well, we have 4 equal pieces here. If I was to simply slice horizontally in thirds, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I already have 3 horizontal pieces here. If I was to simply slice vertically into 4s, then I would also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But not only that, look what we also have. Now we have these portions that are comparable to each other. Again, my picture is not drawn to scale, so they might not look exactly the same, but now we see that all we have to do is, out of these 12, we have 1, 2, 3, 4, 5, 6, 7. 7 out of 12. Now let's do that algebraically over here and see how it turns out. We're going to take our 1/4 and we need to somehow turn that 4 into a 12. How can we do this? Well, if we have 1/4, we can multiply the 4 by 3. But if we multiply the bottom number by 3, we also have to multiply the top number by 3. What does that give us? Well, 3 times 1 is 3, and 3 times 4 is 12. And so we changed our 1/4 into 3/12. Notice that mathematically this is allowed because of two reasons. One, the same scale by which we increase the top, which is we tripled it, we multiplied by 3. Well, I increased the bottom by the same scale. I also tripled the bottom. So this is equivalent. Also, any number over itself is simply 1. So 3 over 3 is simply 1, and all I did was I multiplied 1/4 by 1, and that's acceptable mathematically. So here we have 3 over 12. Now let's take our 1/3 and try and get this bottom number to be a 12. Well, again, we could multiply that bottom number by 4. But if we multiply the bottom by 4, we also have to multiply the top by 4, and that gives us 4 over 12. Now that we have both denominators being the same, we can simply add them the way we know how to add two fractions with the same denominators like we did before. And now we just add the top, we get 7, and the bottom is 12. And that's exactly what we got from our picture, 7 over 12. Hopefully you found this video useful. Don't forget to like, share, and subscribe.